Okay, so on this 9-3, we're doing the solving by square roots. And the big piece of this is that you can do it any time that b is equal to 0 and that middle term is missing. So anytime that your quadratic looks like that ax squared, of course that has to be there for it to be a quadratic, and then maybe you have a constant as well, but the degree 1, the x term degree 1 term that typically makes it a trinomial is missing. Okay, so it's just the x squared term and the number. This lets you use that square root method. And I actually informally introduced y'all to this when we were doing some of the graphing stuff in chapter 8. There was a few problems where like find the zeros, and I showed you, hey, you could use difference of squares, or you could just solve for x squared. That's the big idea today. The big idea is that when it's like this, 2 quick steps will get you to your solutions. Isolate the x squared variable with the typical inverse operations that you're used to using. And then once that x squared is all by itself, the only additional step you have to take is take the square root of both sides to get rid of the power. Okay? And that's it, and that solves for x. Okay? The other thing is, you know, as you're doing, because you're taking square roots, what kind of numbers can we not take the square root of? Negatives. We cannot take the square root of a negative number. There's no real solutions to that. So that really means that when you isolate that x squared and get it by itself, if the number on the other side is positive, then that always has 2 real solutions. Any positive number greater than 0 has 2 real roots when you take the square root. Remember that positive, negative. Okay? That means that parabola hits that x-axis at 2 different locations. So just like you wouldn't ignore one of those x-intercepts if you were solving by graphing, you'd want to make sure you give the location of both of them. Same thing happens here. You'd want to make sure you give both answers. One will be a positive, one will be a negative, but they're both just as equally important answers, right? If it's equal to 0 when you isolate it, then it only has 1 real root. It'll just be 0. That will be the one place that it intersects the x-axis. It'll actually be at the origin. And it'll only have one solution, x equals 0. And then probably the biggest one is if, when you isolate x squared, this is negative, the number on the other side is negative, you cannot take the square root of a negative number. So that has no real solutions or real roots. Okay? So let's practice a few of those. All right, so let's try a few like this, right? So these are all, if you look at them, you right away you can tell these are good candidates for square root method because I don't have an x term, a degree 1 term. I just have the x squared term and the constant. So 2 steps. Isolate the x squared term by doing those inverse operations, and then take the square root of both sides. That's the moral of the story. Okay, so let's try number 1 really quick. X squared is not by itself, so we need to do that work. We'll move the 49 by doing the opposite operation. So we'll add 49 on both sides, right? That leaves just x squared by itself on the left side. On the right, what is 0 plus 49? 49, right? And look at that. If this is by itself and it's equal to something positive, this is going to have 2 real roots. Okay? Whatever the square root of 49 is. Okay, so the last step to get rid of the power is just to take the square root of both sides. This is the inverse of a power. That root is the square root is the inverse of a power of 2. So that's how we end up really isolating that x. And then the square root of 49 is what? And negative 7, right? So again, don't leave off that second one because that's like only giving half the answer. Same thing, you know. If you graph it, that would be like just choosing one x-intercept and then not giving the other one. Make sure you list both. You could write it like this with a double positive negative sign, or you could separate them out if that makes it easier and remind yourself. But the moment you get to this step and you see you have a positive on the other side, it has 2 real roots. Make sure you give both. Okay? But these are our solutions. If we were to graph this on our graphing calculator right now, you would see right away that this parabola intersects the x-axis at positive 7 and at negative 7. Okay, so it's consistent with that method. Okay, let's try number 2. So on number 2, We want to isolate x squared. We'll do the inverse of adding 64, which is subtracting, or negative. That leaves us with x squared is equal to a negative 64. If that is fully isolated, that x squared, and it's equaling a negative number, how many solutions are we going to have? None. I'm not going to have any because I cannot take the square root of a negative number. So if I get this all by itself and I see it's equaling a negative value, then I know that I'm not going to be able to proceed, because if I try to take the square root of a negative here, I'll get an error message on my calculator. It won't work. There's no real solution that makes this true. Okay? So this is no real solutions. 3 and 4 are the same idea. They just start to have a little bit more stuff we need to kind of eliminate to get x squared by itself, but that's all review. If you look at number 3, you could add 72 on both sides first. That leaves us with 2x squared is equal to positive 72. And then for this one, it's a little more complex. We have a second step. What else do we have to get rid of? The 2, right? So the opposite of multiplying here is now to divide by 2 on both sides. So we get x squared is now equal to 36, right? Our x squared is by itself. I look on the other side, I see I have a positive. Right away, I know this is going to have 2 real roots, 2 real solutions. Okay, so I just take the square root of both sides to discover what that is. So when I take the square root of both sides, what's the square root of 36? Positive 6 and negative 6. So those would be the 2 real roots for this particular quadratic. Somebody else asked this in a different class, so I'll bring it up. Someone else asked, well, instead of doing like moving the 72 and then dividing by 2, if I see that there's like a common number, could I divide it out first? As long as you do the whole side, the answer is yes. Like here, they say, well, could I divide the negative 1 out of both sides? And if you do the entire side and make sure you divide both the full side by that negative, you can do that. So if I divide both sides by negative 1 here, I get x squared plus 12. And on this side, I get a positive 12 as well. Okay, like here you could have divided both sides by 2, as long as you do the entire side, right? And then we could move the 12 after that. So we get x squared is equal to, what's 12 minus 12? 0. So when it's equal to 0, it's not positive, it's not negative, it's just 0. How many solutions will we have? 1. Right? And you can see that because as we keep going, when I try to take the square root here, that will cancel my power, but the square root of 0 is just 0. Y'all don't put plus or minus 0 because that's nonsense. That's just gibberish. Don't do plus minus, it's just 0. One solution. That actually means that your vertex is, that your vertex is right at the origin, and it's just touching the x-axis at that single location. Okay? So just one answer or one real solution right there. All right. Oh, how do we feel about those? Are we okay? Yes, it is. Up here, I changed it, but that's fine. Yeah, you can just cross it out. So number 5, don't do that one. But I do want y'all to do 6, 7, 8, and 9. Is that what y'all have on? No. Sorry, 6, 7, and 8. That's what I meant. So try 6, 7, and 8. Give y'all a head start. Y'all can check it as you work it out. For this one, I'm going to isolate that x squared by subtracting the 16 and then dividing by the negative 3. So this is a really good example. Actually, let me back up for just a second. Look at number 6, right? This is a really good example of why it's important to wait until you have fully isolated that x squared before you make any decisions. Right? Because the way that this looks right now, after I subtracted that 16, or even maybe before that, if you see the negative on the other side, you might mistakenly say, oh, there's a negative on the other side. That's going to be a no real solutions. But I'm not quite done yet, right? What's going to happen when I divide by that negative 3? It's going to turn that into a positive, and then you're going to realize, oh yeah, this did have solutions all along, right? I just didn't catch it because I kind of jumped the gun and went a little too fast or too early. So make sure you have fully isolated x squared before you make any decisions. right? Once that x squared is really, really by itself here, it's equal to a positive 9, and that is going to have two real solutions, okay? So if we take the square root of both sides, that cancels the power. X is equal to the square root of 9, which is positive and negative 3. Good. Okay. One more. Let's see, number 7 here. We can move the 9 to the right side. Rewrite this as 25x squared is equal to a positive 9, then divide by 25. Now, does 9 divide nicely by 25, y'all? No. So then guess what? Just leave it as a fraction. I promise you, not only are fractions in general most of the time easier, but what kind of numbers do you see in this fraction? They're perfect squares, right? And I'm about to take the square root. I promise you, this is going to be easier leaving it as a fraction than having to deal with some decimal that is not going to look like a perfect square to you. And then you're going to have to reach for the calculator and all that, right? So leave it as just 9 over 25. And then we take the square root of both sides here. That cancels that. And x is just the square root of 9/25, which is just the square root of the top and the square root of the bottom. So what would that fraction be? 3/5, yeah. Yeah, you got it. Perfect. Okay. So if y'all feel good about those, flip it over. Okay. These look a little bit different, but they're actually very similar to what we just did. But more importantly, they are really critical to what you're doing tomorrow. Tomorrow, you're going to learn, that's when it kind of gets real, okay? You're going to learn a new method that really will look very new to you, that will be really important for Algebra 2 pre-cal stuff, called completing the square, okay? And what you're about to do here on 9 through 12 is really setting the groundwork and getting you comfortable and ready to complete the square. So a minute ago, we talked about if we isolate that perfect square on both sides, right? On these problems here, we isolated the x squared, took the square root. We isolated the x squared, we took the square root. Okay? Well, I know this doesn't look exactly like it, guys, but I want y'all to just understand that here on the left, for example, on number 9, that's still a perfect square. It's a perfect square trinomial pattern, but it's still a perfect square. It's still a quantity to the second power. So I can still use a square root on both sides to drop that exponent. And you have no idea how much work you'll get to avoid and kind of, bypass if you catch that and you do that here. Because the other option is foiling this out or turning it into a perfect square trinomial, which by the way turns it into a trinomial, so I can't use square root method anymore. I got to go now and factor or graph it or use other stuff, and it's a lot more time consuming. But if you realize, hey, this is still a perfect square, a base raised to a second power, and there's nothing else around it, it is isolated, then we can just take the square root of both sides here, and it completely just drops the exponent and turns what would have been a pretty complex quadratic into just that simple x minus 4 one-step equation. Pretty nice. Okay? Now, the delicate part that requires a little extra attention is on the other side. Because what's the square root of 100, guys? Say it again. And negative 10. You've got two roots, right? We just talked about that. So there are really two roots hanging out over here. Okay? So you could either separate it at this point now and say, oh, I really have two equations. I have x minus 4 equals 10. And I also have x minus 4 equals negative 10, right? Or you could move the 4 first. I'll show you both methods. You can see which one you like better. But I still have to acknowledge that when I'm solving for x, there's two situations happening here, guys. There's a positive 10, right? So one answer is positive 10 plus 4, which gives us a solution of 14. But then there's also the other solution, which is a negative 10 plus 4, which gives us negative 6. These are the x-intercept solutions, zeros, roots, whatever you want to call them, right? That is the solution to that quadratic. This is where those x-intercepts live on the graph, okay? That's the part that needs a little extra attention, and it's going to be really important for what we're doing over the next 3 or 4 days after today, okay? So being comfortable with this is really beneficial. So just remember 2 roots, and then when you isolate, or if you didn't like this, you could have set it up from the beginning. So let's try it again over here on this side, right? This is isolated, my perfect square. Breaks to the second power, there's nothing around it, so I'll take the square root of both sides. That drops the power. I just have x plus 2 is equal to the positive and negative root of 196, which happens to be 14. And then the other option, if you don't love this, if you feel like this is a little fuzzy, is literally write the 2 equations. So one answer is x plus 2 is equal to 14. The other answer is going to be x plus 2 is equal to negative 14. And then you solve each equation out. Okay? But it's still the same minus 2 that you're doing. So whichever way you like to do it. So one solution here would be what, guys? It's 14 minus 2. 12. And the other solution is negative 16. Okay. If, like number 11, there is stuff kind of hanging out around that perfect square power, move it out of the way, like we did on the first couple of problems, right? So if I see a 16 or a plus 5 or any stuff around my power, move it out to the other side. So if they're multiplying by 16, let's actually move that before we do any square roots. Okay? So we'll move that 16 so that it looks more like 9 and 10. So now it's going to be x minus 3 squared. On this side, this does not come out nice, then no big deal. I'll leave it as a fraction, especially since those are perfect squares. Now that my power is isolated, I can take the square root on both sides. Okay, so square root here. That cancels that. I get x minus 3 is equal to positive and negative what? What would be the square root of 25 over 16? 5/4, right? And then you can either move the 3 and find both answers, or you could set up 2 little equations. X minus 3 is equal to positive 5/4, and x minus 3 is equal to a negative 5/4. Either way, you're going to add 3 to solve. Right? So our solution, so 5/4 is 1 1/4 plus that. So one solution is 4 1/4. You can also grab a calculator right now at this point if this is not feeling comfortable. And then the other answer would be 3 minus that 1 3/4. Okay. So isolating that power is the name of the game. Sometimes it's just an x, sometimes it's a sum or difference. But if it's a power, you can still isolate it, get rid of the stuff on the outside of it, and then take the square root to get rid of the power. Yeah. I don't care improper as long as it's simplified. Okay. Great question. All right. How do we feel about this? Are we okay with that? Is it okay if I move on? All right. So the number 6, it's really kind of, that's not number 6 at all. That's number 15. I missed I think I skipped something there. There you go. Okay. So check these out now, because here's the deal. Now that you kind of have the idea behind how you solve with square roots, you realize, hey, this is kind of suspicious. Every single number she's come up with is a perfect square. Well, I was being nice up until this point. So hopefully you understand that pretty much making bank that not every quadratic will always have, values that are 9, 25, 16, 36, right? That all worked out really nice. But that's not the real world. We're going to have quadratics that, as we're solving for that x squared and isolating it, don't give us perfect squares on the other side. Okay? And this, guys, this is where it hits. Those 2 weeks that we did before spring break about simplified radical, we're here. This is it. Okay? Because that is exactly how we are going to write our answers if they don't end up being perfect squared numbers. Okay? We don't want to go to awful decimals that we have to round and start to get estimated answers. We want exact answers that are just, clean, easy to read, exact, and just simplified radical form. Okay? So simplified radical form means that our answer is exact. That's why we like it. And it means no decimals. Okay, so make sure you're understanding that. Okay, so that's where everything we did on lesson 9.1 for almost 2 weeks, okay, immediately, comes into play. So let's check out number 13, for example. So on number 13, well, we'll play the game like we did on the first few problems. We'll isolate x squared. Let's add 12 on both sides. We get x squared is equal, what's 3 plus 12? 15. Okay, we notice that's a positive number. So this is going to have 2 real roots. Okay, and to find it, we're going to just take the square root on both sides. Bye, have a great day. That leaves me with just x. And on this side, I know I'm going to have the positive and negative root of 15. And then that's when it dawns on me, wait a minute, 15 is not a perfect square though. Okay, and then that's okay. In fact, sometimes that's good news. That's less work for you, right? So, but all you have to do is say, okay, well, 15 is not a perfect square, so I'm going to leave it in radical form. We're not going to go to decimals. We're not going to try to get, but we need to make sure it's simplified. So if 15 is not a perfect square, does 15 at least have any perfect square factors? No, right? The only things that multiply to 15 are 5 and 3, or 1 and 15. So none of that works, then guess what? Then you're done. It's just a positive and negative square root of 15. That would be how we would leave our answer, because it's not a perfect square. We want to leave it exact with a radical format. We just want to make sure it's simplified. Okay? So that would be our answer for 13. Let's try 14. So 14, we play the game again. All right, let's start isolating x squared. We'll subtract 25. Is that okay? Okay. That leaves us with x squared is equal to, and 49 minus 25 is 24. That's positive, so we're going to have 2 real roots here. Take the square root. These guys cancel. I get the positive and negative root of 24. Is 24 a perfect square? No, right? Hey, can you put it down? That's kind of the whole point. We're not going to work on the calculator on this. All right, so 24 is not a perfect square. So then here's part 2 of that. Did it have any perfect square factors that go into 24? What's a perfect square factor that goes into 24? 4, right? So we're going to need to make sure that 4 is out of there before we box our answer. So we can say, you know what? I know that 24 is 4 times 6. And I know I can take the square root of the 4 and then leave this guy behind inside the radical. What is the square root of 4? 2, right? So we end up really with positive or negative 2 square root of 6. And that would be how we would write those solutions. Okay? This is a little more realistic because a lot of times we're not going to get those nice perfect squares. Try number 15. If you haven't already started, try 15. And again, we're leaving it in simplified radical, no decimals. We just want nice, exact, clean answers. But do make sure it's simplified. There's a little bit of a head start there. So x squared is equal 15 over 6. 6 doesn't go evenly into 15, but can that be simplified, 15 over 6? What goes into 15 and into 6? 3, right? So I can simplify this by a factor of 3 and just get 5 over 2 here. And then all I have to do is drop the square by just doing the square root. So this is what I'm going to do here. This will cancel the power. So I'm getting the positive and negative root of 5 over 2, which is fine. Those are not perfect squares, but that's not simplified, right? This is why we spent all that time. So we need to make sure we simplify it. First of all, the big red flag that should be going off for you is that there's a fraction inside a radical. That's like one of the first deal breakers. We can't have fractions inside. So that's pretty easy to fix. We'll just separate out the radical and take the square root of the top along with the square root of the bottom. But then, what else do we see right away that is not simplified? There's a radical in the denominator, exactly. So we might say, oh, no, wait, but there's a radical in the denominator, so I have to rationalize the denominator by creating a perfect square down there. Okay? And so when I do that, I really get square root of 5 times square root of 2 is square root of 10. And then square root of 2 times square root of 2 is just positive 2. And now we can say, okay, there it is, fully simplified. That is the solutions. Positive square root of 10 over 2 and negative square root of 10 over 2. Okay. Okay, so number 16, I'm going to go a little bit quicker. I'm going to subtract 20 on both sides here. That gives us a negative 4x squared is equal to a negative 2. Now we divide both sides by negative 4. So that tells us x squared has to be 1/2. And then when we take the square root of both sides, cancel the power, we're looking at x equaling the positive or negative square root of 1/2. But that, again, has to be simplified. So we'll put the radical in the numerator and denominator, and then we will rationalize that denominator to get rid of the radical in the denominator. So when it's all said and done, x is equal to positive or negative square root of 2 over 2 for number 16. So for number 17, you have a ball that is dropped from a window at a height of 81 feet. And then they give you the function that represents the height of the ball at any given time after it's dropped. So we want to know how long it's going to take for the ball to hit the ground, which really means our height will be 0 at that point. So all we're really doing here is taking this equation and trying to find out when would the output or the height end up being 0. Well, that's when we'll be 0 feet off the ground. And then because that b is 0, that middle term, this is a great candidate for solving by square roots. Just isolate the x squared. So that leaves us with a negative 81. Divide by the negative 16. You get x squared is equal to 81 over 16. And then to get rid of the power, you take the square root of both sides. That cancels that. So x is going to be equal to the square root of 81 over 16, which is 9 over 4. You might notice I don't have the plus minus in front of that this time because it's a word problem. So we got to think about the reasonableness of our answer. And in this case, guys, a negative is not reasonable. Right? So our solution here is it's going to take 9/4, which is about 2.25 seconds, if that helps. Okay, on the last one, we're going to work with the volume of a cone. And they give you the formula here. The volume of a cone has the following formula. You've got volume equals 1/3 times pi times the radius squared times h. And the first part of this problem just asks you to solve the formula for r. So that means we're going to isolate the radius here by getting rid of everything on the right side. My strategy here is to get rid of that fraction as quickly as possible. So I like to kind of just come in and say, hey, sorry, wrong ink color here. Try that again. Times 3 on both sides. And what that does is 1/3 times 3 is equal to 1. It cancels that out. And I really don't have to, worry about having a fraction here anymore. So now I have 3 times the volume will equal pi r squared times h. Next step for me to isolate r is get rid of pi and the height. So pi and h are both being multiplied, so the inverse for both of those things is division. And I could do that in separate steps, but why take separate steps when I can do them both together? I can divide by pi and h, by both of those values, and it cancels pi and it cancels h. And so now I'm getting really close here. I've got 3 times the volume divided by pi times h is equal to r squared. And now we start to see why this is in this lesson. Like, oh, okay, now I'm at r squared. Last step is just a matter of getting rid of the power like we have been by just taking the square root of both sides, which cancels that power. So for the first part in this problem, we can rewrite this formula and express the radius of a cone as the square root of 3b over pi times h. Okay. For the next phase of this, it then says, then find the radius of the cone with a volume of 27 pi cubic inches and a height of 4 inches. So now it's giving me some specific values to plug in here. And we'll start off by just rewriting this and inserting those values for the volume. So volume is now going to be represented by 27 pi. And the height will be 4 inches. And if we clean that up there on the inside, we're going to get 27 times 3 is 81 pi in our numerator here over the 4 pi. And I've always said this, I'll continue to say it, always try to simplify what's in there before you start dealing with the radical, right? So if I have a fraction like this and I see some stuff can simplify or cancel, that's always a really smart choice. For example, here right away I can tell that pi over pi just cancels itself out. Anything over itself is 1. So that really leaves me with a radius that is just the square root of 81 over 4. Luckily, those are both perfect squares, and I can evaluate that square root completely and bring it down to 9 over 2. And again, I'm ignoring the negative root here because in the context of a real situation like this, where the number is going to represent a dimension, a length, a width, some sort of measurement, negatives are not going to make sense for that here. So we're going to stick with just a positive root, which would be 9 over 2, or in other words, 4.5 inches. And there's your radius.